builds in with my action plans through the project, and that is I'm building it's like an awesome brick type template that I'm going to use for just basically as we progress through the course and like progress through the development, people will be like very hands on with it, and the step by step how to implement the React and like demystifying where there's web development and then there's Solidity and then just combining it all together. And so I've just done that through labeling exactly like I put together a Notion and then I'm putting that markup into a GitHub repo, and then I'm just gonna have everybody walk through it in my class or all the developers in my class to like separate the web development from the Solidity and then where they combine, just being very specific. And so I did this through creating an NFT gallery app, and so they'll be able to read the NFTs from their wallet pulled from a contract or a specified contract. And the action plan to get back with that is I'll reach out and basically just my first few sessions I'm going to be recording them, and then I'll reach out to Bath and see if like how this just basically how to improve them upon that. And is that okay?
Yeah, that sounds great. I was just wondering if, so you said you had like a Notion and you're putting this stuff on GitHub. Would you possibly be able to share that with us?
Yeah.
That would be great if you want to either post it here in the chat or also in the Discord so people can reference it later. That'd be great.
I have the app up for the gallery.
Oh, awesome.
I guess I can't. Screen share. It's very simple here. Problem last time. There we go. Is it going?
I'm sorry, is what? Oh, yeah, there we go.
Now. Mm-hmm. Okay, so it's just literally as simple as this. And these will be, you connect, or it's not going to work on this guy probably, but you'll be able to connect and then view your NFTs. It's not, I didn't load in any NFTs because you'll need to mint them, but it's just really helping them understand that facet of it.
Okay, pretty cool. Yeah, awesome. So are you minting your own NFTs as well to display on? Okay.
Yeah, so I have to add that to it as well.
Wow.
Like that whole contract.
That's impressive. And was there a GitHub for that somewhere?
No, like honestly, I have not been uploading my GitHub, so I will upload that. Just been going on the fly, but yeah.
No problem.
The minting contract's very boilerplate. Actually, it's from I'm referencing it from I think either Dabbits or I think it is Dabbits for the minting contract, just to keep it very simple.
Okay, very cool.
I'm just going through everything.
Always great to see people bringing new tools in. Awesome. All right. Okay, so if that's everything from you, Ryan, was there anyone else who had something they wanted to present before we just hop into like help mode, kind of help mode / demo mode?
Yeah, I also just had my plan of action that I wasn't able to present last Monday.
All right, awesome.
Last week.
Mm-hmm. Yep, go ahead.
Yeah, I'll just talk about it. But I'm part of Women in Computer Science club in my university, and we don't really have a blockchain club yet. So one of the things I wanted to like start doing is hold like a series of like info sessions and maybe turn into workshops for the club and invite other people too from the university. So like just the steps I'd be taking for that. I'm I'm like a director in the club, so like I just have to talk to the workshop director about that and see how many people would be interested. I think something that I'd really want to go into would be like the Solidity workshop. I've been doing the Crypto Zombies website, and I think it's really helpful. Like it breaks it down properly. So I was doing that, writing notes, and also while I was building my project for BAF, I was also like breaking it down into tiny little pieces. So if I do create my workshop, then I have that ready. It's not public on GitHub yet, but when I do publish it, I mean, make it public, then I will share the resource on Discord. And yeah, that's about it. I'm also creating kind of like an NFT marketplace. So
A whole NFT marketplace? That sounds pretty cool.
yeah.
Awesome. Yeah, so absolutely, if anyone has like GitHub repos or blog posts they're writing, course materials or anything that you think other people might find helpful because, maybe you learned from it while writing it or someone else could learn from it through reading it, definitely share that in the Discord and stuff. And I'm definitely looking forward to following up with all you guys in a couple months and seeing where this all has taken you. So yeah, and always super happy to help support you guys in any way possible, any way I can. Right. All right, perfect. So, if that's it for additional presentations, I think we can hop into help/demo mode. So if anyone has any questions or just wants to like re-clarify something or demonstrate something you've been working on, feel free to just shout it out. I am here for you. Oh, and let me also double check that everybody got the email that I sent out earlier this week. Did anyone not get that email? There's something about what the last 4 sessions of the Web3 TTT is going to look like. Pretty much what that means is, so today is the help session. So get out all of your, anything you've been stuck on if you're debugging something. And then on Monday, that's going to be demo day, where we're all going to demonstrate what we have been working on throughout the track. And then, so that's next Monday. And then Wednesday is going to be the last day. And we'll get certificates out to you guys then. NFT certificates. So, yep.
I just had a quick question. Just wanted to get your opinion on like if you think writing code in Remix is better or VS Code with a Solidity extension.
It depends on the size of the project, in my opinion. I think Remix is good for like mocking things up, and then once you have either a more complex contract structure or just a more complicated project, or you have multiple people working on the project, and especially once you're deploying, I would not recommend deploying to mainnet from Remix, just because you have a lot more control over exactly what happens if you deploy, with everything configured manually. But for testing and mock-up purposes, yeah, I think Remix is a great tool. It might suffer a little bit on the developer experience side of things, I think. I think you can get a little bit more robust tooling and developer experience, like support like autocomplete and like inline errors are a little bit better, I think, if you use a fully fledged editor, but that's more a matter of personal taste. I like to use VS Code because I have some editing extensions set up so I can write code a little faster. But mocking up and stuff, I still use Remix. So I think it's mostly a matter of personal taste when it really comes down to it. They both excel in different areas.
Okay. Thank you.
Mm-hmm. Now, I actually have a question for you guys. Let's see. So I was talking with someone earlier today about how to calculate the square root of a number in Solidity. And, you know, it's kind of a unique situation because Solidity doesn't support floating point numbers. Like, they have like the fixed point number data type, but I don't think it's very well supported yet. And that's kind of the closest you can get. And obviously the standard library as far as like math tooling is pretty sparse. You know, you have your more or less standard safe math library, but there isn't like a, you know, more complex, you know, something that's going to provide you like an absolute value function, a logarithm function, a square root function, a power function, something like that. Not quite as available in Solidity, especially because they only really have good support for integers. So if anyone has found in their research like a good solution to that, I found a couple. Looking around, I found one from Uniswap and another like pure math library that had a square root implementation. I was just wondering if anyone had found something that might be a little more either simpler or more robust or something like that for square root, or just, you know, a richer library of math functions.
I honestly have not, but I've ran into a lot of problems that you're running into.
Yeah, like
up there that
just having the light, very lightweight support for anything math related. You have your basic 4 mathematical operators, and that's kind of it, right?
Yeah, those bonding curves. That, like, if you're just any sort of like intensive math or calculus, this is horrible.
Right. So,
But
I
what
don't
was the
know.
solution you came up with, or like, what did you find?
Yeah, so I guess I can share those links that I found. So Uniswap version 2 implemented a version of a square root function. Let me just paste that link here. Obviously Uniswap is on version 3 now, and I couldn't find an implementation of just a plain square root in that code. Also, keep in mind this is let's see here. Yeah. So, this is Solidity version 5, and I can't remember if they still do the named returns. They might. I can't remember if that's still a thing. Anyways. So that was one implementation that I found. And then another implementation of square root that I found was from a math library right here. And that one seemed to be a little bit, possibly a little bit more optimized for like some, let's see. Yeah, because I think that this one, the second one, only runs like a set number of iterations, so it might be less accurate. because the first one runs in a loop, and I guess just eyeballing it, like, I'm not fast enough at math to say, like, oh, this one's going to be more efficient or this one's going to be more accurate. But just based on the fact that the Uniswap one is using a loop, I think it has the potential to run longer than 7 iterations. But I guess I haven't run the numbers, so I can't say for sure. Could always, just do a gas comparison between the two and see which one fits your needs. But kind of on a more general note, I suppose, when it comes to doing this sort of calculation, if you're doing like difficult calculus or finding roots, complex roots or something like that, doing a lot of math and Solidity, like, I'm not saying that it's always like a red flag and you need to redo your contract, but it might be worth considering saying something like, okay, Solidity is not designed to be a language where you do a lot of computation, right? It's not designed to be the language where you're not drawing frames, you're not drawing like ray traced video game frames to a video card buffer, and you're not trying to mine cryptocurrency or solve complex mathematical formulas or run physics simulations or anything like that. That's not what Solidity is for, right? Solidity is for is for keeping track of data and validating things, right? So you're not, if you're doing these super complex calculations, I'm not saying that you shouldn't be, but it might be worth considering, can I offload this calculation and say, okay, I'm not going to actually do the calculation in my code. Someone else can do it by themselves, give me the answer, and I'll verify the answer, right? Like, your contract might not need to do the calculation, because all it actually has to do, possibly, is verify the result. So when it comes to like square root or something, if you need the square root of a number, rather than calculating it in your code, would it maybe be possible for the person calling the function to calculate the square root for you, and then you just check it, right? Because it's fairly easy to check a square root. You just multiply it by itself, and then obviously, since we're using integers, there's going to be a little bit of error there. So you just say, okay, I'll multiply the two integers together, and if error is within a certain amount, then I'll say, okay, that's a good square root, right? And that's a lot cheaper than possibly calculating the square root for yourself. So consider that as a possibility if you might be needing to do a lot of complex calculations in your contract. Consider that as a gas saving possibility. But again, like, if you need more reliable, like if you actually have to have the calculation in your code, well, maybe just try and optimize the algorithm.
Taking note of that. No, I'm literally writing that down for my students.
Hey, Jacob, what do you think about offloading, if it's really heavy calculations, offloading it to an Oracle?
Yeah, that's a great idea. Right, because Oracle can perform that calculation. It can grab that data from somewhere off-chain, and whatever it's doing off-chain, like, that's no skin off your back, or whatever the phrase is, right? It doesn't cost you anything in gas.
Right.
Yeah.
Yeah. It's just that there may be just a little bit of a latency issue, but that's
right.
Probably it.
Mm-hmm.
Right. Yeah.
Yep. So it depends on your needs, but if you think of Solidity as less of a processing language and possibly more of like a verifying language, smart contracts, sometimes the language is confusing because it's like, oh, a smart contract, but it acts so much like a Java class, right? Like, I learned Java long before I learned Solidity, and so when I was learning Solidity, I was like, why don't they just call it a class? It's basically a class, right? It's kind of like somewhere in between like a class and a struct, or like, it has a couple of unique properties, but why not just call it a class? Well, part of it is because, it's a smart contract. It's not necessarily made to do all this complex processing. It's made to do, some simple data storage and verification. I might be being a little too general here, but smart contracts are there to verify things on chain, and in my opinion, they're not there to do much more than, okay, I'll verify this data for you. If you want a lot of data, here's a hash of the data. You can go find it on IPFS. Or, here's a web address. You can find that somewhere else. I'm not going to store a whole image for you, but I can tell you where to get it, right? It's going to verify data and point you to more data. So maybe that helps, and maybe it makes the naming of, it's a smart contract make a little more sense. I don't know if that helps. Maybe it does. Maybe it doesn't.
I have I just come up with something like, you remember there was a class there you have a contract called a very expensive token.
Yeah.
I think you take 2 to the power of total supply, something like that.
Mm-hmm.
You put the 2 times together, so 2 stars together.
Mm-hmm.
So I was just wondering if you just put 2 stars and 0.5. So does that give you the square root?
I don't think so, because I don't think Solidity is gonna like the floating point number.
Oh yeah. Okay. Yeah.
We could try it.
The question is to what extent can I run the code in the remix? Do I have to deploy it and use all the MetaMask, all of that to
Yeah,
run
it would be nice if there was some sort of expression, evaluator, like the JavaScript console or the Python REPL. But I don't think there is. I mean, there might be something like that for Solidity. I guess I haven't really checked. I've just never heard of it. That might be an interesting thing to look up here.
We basically write the entire code and make sure it's correct, and then we do all the MetaMask, all of that.
Yeah, I mean, that's where Remix is really helpful, because you can just whip something up really fast, deploy it in your browser, and play around with it. Oh, it looks like okay, so there is a project I found on GitHub that's literally called Solidity REPL, but it was last updated in January of 2020, so looking kind of old. I actually have never even... Wait, is this a thing? Oh no, that just takes me to the same. Okay. I suppose I should be sharing my screen so you can actually see what I'm looking at here. Alright, yeah. So I just pulled up this here. So I looked for Solidity REPL, got this project here, and then the documentation for Solidity 0.4 just has a link here to that same project. But it just doesn't look like it's been updated since January of 2020. If anyone else knows of something like this, what might this be here? No, this looks like that's the same project. Is this just some sort of... Yeah, okay. Don't know what that was. Doesn't look like there is such a thing. ETH Fiddle? Is this basically Remix? Yeah. Doesn't even have the latest version of Solidity. Alright. suppose I can come over here and let's try and just make a new contract here. And then we'll say and say like we do 4 to the power of 1/2. It's not even going to compile it. It won't even compile that. Interesting. I wonder if I don't know, because that would
Easily do that in like Python.
Right, yeah, you can do that in Python. I guess they're too smart for us. Yeah, that power operator doesn't like that at all. It's not even going to compile it. That's interesting. I would have thought that it would accept it, but then when it actually ran it, I would expect it to round this to like 0, or not round, truncate it to 0. That's what I would have expected. Interesting, but yeah, good try, but no cigar. Looks like. Let's try this guy. So here, let's say square root 4, and what does this say? Can be restricted to pure. Sounds good to me. All right. Yeah, SPDX, cool. And let's deploy this test contract here. And yep, gives me 2. Lovely. And then this long thing here. Grab that. Paste him down there. See if this guy works any wonders. Call this square root 2, I guess. Try that.
Like, or can you try like the square root of 5 or something like that? That doesn't give you integer.
Okay. Here, I'll just do this. Alright, and then we will compile things and deploy that again. Don't need that, thank you. So I will try 4, that's running this longer method here. 2, if I try 5, gives me 2. 7 gives me 2. 8 also gives me 2. And 10 gives me 3. And if I try something really big, so 100, 1,000, a couple, add a lot of zeros. Okay, apparently that one was not nice. There we go. But then I suppose, so this one would have ended up being fractional. So then if I come over here, see what this actually squares to, pretty close, but obviously we're working with integers here, so.
It's always gonna be a very accurate approximation.
Yeah. Actually, let's compare these two. I'll make these just public. So I don't have to worry about that. You can just square it. Call this uniswap. And call this one PRB. Whatever that stands for. PRB. Alright. Cool. So, oh, and I suppose we can compare gas here then too. Alright. So let's try squaring or square rooting. Oh, I don't know. That's 7 nines. Alright. So this guy took us. Oh, here it is. 22,000. This guy took us 30,000. Interesting. So the Uniswap one is, at least for this particular number, is more expensive. Interesting.
Do you think that's like very expensive?
Sorry, I only heard the first half of your question.
In absolute terms, it's an expensive calculation for Solidity.
Well, I mean, square root is unless you find, unless you're dealing with a special case like square root, I don't think is a terribly inexpensive computation, right? It requires some work. It's like division is not a cheap operation for a computer to do. Square root is also not cheap, so I suppose here.
Hey Jacob, what do you think about like a lazy cache that stores, especially if the square root's going to be within a range?
Mm-hmm.
So let's say we know that the square root's going to be between 1 and 20, and you're going to get an integer between 1 and 20 that you have the square root. Why not just preload a cache or lazy load a cache that stores a mapping, basically, that stores the results already? So I'm going to square root 4. I don't need to calculate that. I've done it before, maybe.
Mm-hmm.
Why don't I just cache that and then look up that cache? And if it's there, I've got the solution without having to calculate anything.
Right. Well, of course, that's going to require a lot more memory if you're calculating a variable number of square roots. Like if you're calculating a lot of different numbers, like if you only need to know the square roots of like 7 different numbers, then it's probably fine. You could even store those as like constants or something. But you also have to be careful because storing things on chain is also pretty expensive. So we can mock something up. Let's say mapping from uint 256 to uint 256. And let's call this square roots. And then square root store uint x. Say it can't be pure, so it'll be public. Returns uint 256, like so. And then, so we'll say, so this is going to be lazy. So if we don't have the square root stored, then we'll calculate it and store it. If we do have it stored, then perfect, we'll return that. So we'll say,
yeah. I mean, or it could be a hybrid of lazy. I mean, you load up, let's say 1 to 10, but then the rest is lazy added to the cache. To eventually you don't recompute it.
mm-hmm.
So I think over the long run, especially if you're going to get the same numbers over and over, that you have the square root, over the long run, hitting the cache is going to be cheaper than
I don't know. Looking things up and storing things in storage is a little bit expensive, but let's try it out, see how it works. So we're looking at the square root of x. There, okay, so if lookup is not equal to 0, because 0 is the default value for mappings, return lookup, else we'll compute it using this method, which proved to be cheaper. 6 value equals sqrt prb of x. We'll say square roots of x equals val, return val. Something like that. And this is mad at me because I have a syntax error. Expected opening curly brace and got right here. Nope.
Should be returns.
Oh. Yes. Thank you. Alright. Yeah, having a second pair of eyes on your code always helps. Perfect. Okay, so I suppose this will be a little bit slow to run manually, so I'll write something that calculates the square roots. You know, runner, I'll just call it run. And we'll say public. And then here we'll just run square root store. Okay, so we'll say, let's see, 1. We say to 100. I can't even type today. So we'll do x 1 plus equals 1, thank you. And then, so that will be our storing everything. And then I suppose we can just run it again to look everything up and compare the gas costs. We'll go all the way until 100. Alright, so let's try that. Delete. Deploy. Okay, so square root. I want to just say run. Ooh. Oh, it's... Oh, wowzers. That took it a while. Alright, so let's see. That cost us a lot. 2 million gas, okay, the first time to store everything, and then we'll run it again, and this time it cost 200,000 gas, almost 300,000 gas. I suppose I should write another function that just calculates them all without looking them up.
So, I mean, you're going to take a hit up front. The question is, if,
right,
especially if the numbers are coming, the numbers that you need to square root are within a range they're repeating, then the caching might make sense over the long run.
Yeah. So instead here we'll say square root PRB. We calculate that a bunch of times. Alright. So, alright, let's deploy this one more time and see how much calc run costs. So we're looking for it to cost, we're hoping that calc run costs more than this. And it looks like it costs less by quite a bit, actually. This is admittedly just numbers from 1 to 100. So it looks like, at least in this particular case, let's see, so if we say run, this first run is going to cost a lot because we're calculating and storing everything. And then the second time it's just, so right, we got like 2 million gas here again, if I can highlight that properly. 2 million gas. The second time we run it, it costs like 10 times less because there's no writes, just reads. And then if we run calculating it raw, that costs, yeah, less than half. So looks like in this case it is still better to calculate it on the run or on the fly. Yeah.
Where are you doing the lookup?
Right here, square store, this is going to decide to, so it's going to check here. If we have it, if we do have it, it'll just return it.
Right.
Otherwise, it'll calculate it and store it. So then here, we run it the first time. Every single one of them is going to fail this branch and go in this branch, so it'll calculate it and store it. And then the second time we run it, every single time, it's going to go in here and it'll find it and return it.
Yeah.
Definitely, this is definitely how you should be programming if you're calculating some sort of function. See, this would be really good if this value right here wasn't in storage, right? I don't remember if we went through Solidity storage versus memory versus call data. Did we? But pretty much, I guess the biggest difference is between storage and memory. Two modifiers. Unless you're dealing with the more complex data types, you actually won't see them very much, if at all. But if you're dealing with like byte arrays or strings or something like that in Solidity, then you'll see like the memory and storage keywords popping up. So storage. So this guy right here, oh my goodness, this guy right here is implicitly in storage because it's declared as kind of like a member variable, like an instance variable, right? So those are in storage, meaning it persists across transactions, right? And that's the expensive way to store data. You know, when it's actually on chain. If it's just memory, so if I had like a parameter in here that was like string memory, y, then this guy, this memory keyword right here, that means that y is going to disappear after the transaction is completed, right? And storage variables are expensive, and memory is less expensive, but it doesn't persist, right? The problem with writing contracts on chain is that in order to do something like this memoization strategy, like that works really well if you're writing like a Java class, because this isn't being written to disk, right? That's just going into your RAM, right? And that's still really fast, snappy flash storage. But on chain, this is a storage variable, which essentially means it gets written, like, more or less gets written to disk. Not to disk, it gets written on chain. But
the other thing that it has to be taken into consideration is if you're square rooting up very large numbers,
mm-hmm.
then the square root, the math behind it's because it's a loop, that can be taxing. So it really depends on what kind of numbers you're dealing with. Like if you don't really know what number you're gonna get, and you can't box that range, then obviously calculating it, you have really no choice.
Yeah.
But if it's like, well, I know I'm gonna be square rooting between 10,000 and
let's try it. Let's say like multiply this by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I mean, because if we're dealing with, I don't even know how many digits that is anymore. Let's multiply it by 1 ether, actually. Okay, because chances are, I mean, in Solidity, you're going to be dealing with values that big, right? So let's try that. So times 1 ether. Let's see how much that changes our efficiency here. Good call out. Let's see. All right, so run is the one we have to run twice. I should clear this. All right, run. This is gonna take forever. I killed it.
I've never seen that.
Out of memory.
Yeah.
All right. So it's All right. I
maybe,
guess-
maybe make maybe make the number a little smaller.
I killed it.
Yeah.
All right. All right.
We saved. It saved it.
Yeah. Okay. Yeah, we're good. All right. So not 1 ether. I wonder if it was 1. I don't know if Solidity is like garbage collected. So it makes me wonder if it was like trying to calculate one of these that killed it, or if it was like, oh. Well, okay, let's try just doing 10 of these really big numbers then. See if that still dies. So, all my deployed contracts are gone. Alright. So let's try just doing 10 numbers and see if that's still... Oh, is it done? Okay, so that took about 200,000 gas. Run it again. And it takes 50,000 gas. Alright, and then our calc run takes 30,000 gas. 34,000 gas. Okay, so when we're dealing with at least these bigger numbers here. Now see, these are still going to be like kind of nice round numbers because it's going to be like a 4 with 18 zeros after it. So we could try and add like 13, or just some like random extra bit on the end to kind of mess it up and make it not so round of a number. No way, it's too small. We'll try that. No, this is literally just me playing around in alright. Playing around in Remix. Alright, so our first one. Okay, 200,000. 50. Okay, so that got more expensive. That's interesting. It shouldn't be that much more expensive. And then our calculate one, a little bit more expensive. Still 50 versus 35. Still winning. Calculating it on the fly is still winning. Storage is expensive, man.
Yeah, and it's also storing bigger and bigger numbers, right? So.
Shouldn't make a difference. It's taking 256 bits, no matter what.
Oh, that's right. Yeah. Can you paste that code? I want to play with that.
Yeah, sure. I'll put that in the Discord, actually. Oh man, it says it's too long. I guess I'll upload it as a file. Hold on. Alright, there you go. Now it's in the Web3 TTT chat. Or Discord, yeah. Well, that was pretty fun. At least fun for me. Hopefully everyone else enjoyed that or got something out of it.
I mean, obviously, if you can get something with less gas, you can put out a smart contract that other people can use.
Yeah.
Right.
Yeah, well, hopefully you guys found that helpful.
What channel?
I learned something.
What channel did you paste it on? The Web3?
Yeah, Web3 TTT in education.
Okay, got it. Thanks. Yeah, that was fun. Appreciate it. Thank you.
Yeah, absolutely. Any other questions? It looks like we only have like 7 minutes left of the session. We can keep playing with the Solidity. I always enjoy that.
I missed the part you came to be able to deploy. So
Deploy the contract, like just right now, today, like where just pressing the deploy button here.
yeah, we are on like a test net, right? So all the gas is not real.
Oh yeah, this is all fake. This is all actually in browser. Well, I think so. JavaScript VM. Maybe it's calling. I suppose.
This REPL or
Yeah.
something,
It's a simulated.
Yeah. The JavaScript VM options here are all fake. I don't know if Berlin and London are actually locations or if those are engines, like names of engines. Because it's like you can see the tooltip here. It says execution environment does not connect to any node. Everything's local and in memory only. And obviously my browser ran out of memory. So these must be like Solidity, like JavaScript engines that are just named Berlin and London.
I think of the remix that you're using. It's not the remix, right?
This is Remix.
Open remix, I cannot deploy anything. Like you already connected with all the that.
I'm sorry, you're kind of like cutting out every other word or something. So I didn't quite hear what you said. Sorry.
Remix, the remix website, right?
Yeah, so this is just normal, regular old Remix. You click on this tab here, which is the Deploy and Run Transactions tab, and then just the very first option, make sure that your environment is set to JavaScript VM. You don't want it to be injected Web3 or Web3 provider, otherwise that's going to go and try and connect to like a real node somewhere. I mean, like a real node, either a local node or a testnet node or a mainnet node. But it'll try and connect to a node somewhere. You want it to be JavaScript VM, one of these two, for testing. Like if we're just like spitballing stuff here, you want it to be JavaScript VM.
Tell the contract like before you can see the deploy button on
this deploy button. So you have to make sure to select a contract here. Make sure you have like accounts here. This gas limit is set to be like super high for when you deploy your contract, and just so that you don't have to worry about running out of gas. You can leave this as 0 unless you're doing payable functions, and then select your contract here and say deploy, and then it'll show up down here. Oh, not here, right here.
the contract part of my screen is locked. Like I can't select anything.
Oh, make sure to come over to this tab here and click compile. That's probably it. I have auto compile checked so that every time I make a change, it just recompiles it. They should really have this checked by default, but they don't. So make sure to click the compile button. That's probably my bad. I should have clarified that beforehand. Was that it? Did that help? Hopefully that helped. All right. So did everybody get the attendance link for today? Let me just paste that in one more time. And that's probably it for today. So unless anyone has any other questions, I think we can probably call it good and see you all on demo day on Monday.
Thank you, Jacob.
Yeah, thank you so much for coming.